Hello everyone. Today we're going to solve the frequency of the most frequent element problem. This problem basically gives us an array and they give us k operation, and in each operation we can choose a number and increase them by one. And finally we need to return the maximum possible frequency of an element after perform at most k increments. And for example, if we have this one, right, and the frequency of most the frequency of the best element we can get is 3, and we have k equal to 5, right? And how can we do that? So basically we're gonna increase all of the element by uh, to the point where all of them equal to 4, and we're gonna have 1, 2, 3, 4, 5. We're gonna need 5 operation to do that. And then so the idea for this problem is that first of all we can see that if we sort the array, the result is not different with without sorting. So to make it easier, we're going to sort the array first, and after sorting we can see that if we consider each of the segment like this, right? So if we want this problem to have the same value, right? We're gonna increase all of them to the highest value in this segment. For example, if we want all of this segment equal to uh, equally, we're gonna have to increase them to uh, 5, and we're gonna need 4 operation to do that. And we need to make sure that the number of iteration and the number of operation is less than or equal k. So that's the idea of the problem. And how can we do that? Basically, we can just use a sliding window, not sliding window, it's like two pointer problem. So we're gonna start with the left right here and the right here, and we're gonna increase all of the element equal to the right element. This is because we already sort the array, right? So for example, if the first one you have right like this, so the result gonna be 1 1, right? And then we increase to this, and we can see that right now we need to increase this problem by 1, right? So we need 1 operation to do that. So the new result gonna be 1 to 2, right? So the result gonna be 2, the length gonna be 2. So we continue to move the right to this position. So if we move to this position, we're gonna need to increase all of these elements to 4, right? So we're gonna need 1, 2, 3, 4, and 5 still eligible, right? So the new result gonna be 1 and 3, and then we move right to the next one. And until now, we can see that we need to increase all of these elements to this position. So we're gonna need at least 8 operation to do that, right? But we don't have that much operation, so we wanna what we're gonna do is that we will increase, we will shrink the windows so that we can have less operation to increase all of the element to 5. So what we're gonna do is that we're gonna increase left to this, and the number of operation we're gonna need is 4 instead of 8. So we will continue until we consider all of the right position so that we can get the longest one, right? And how can we do that? So this one is a two pointer problem. So that's why first of all we're gonna need a left pointer, and as I mentioned before, we need to sort the array first. Need to sort it from the beginning to end, and then we're gonna for loop try from 0 and try less than size of of the array, and we increase. Uh, and now we need to uh, update the sum of the segment. For example, for this one, right? If we consider this this segment, we need to know the current sum of 2 and 4. So to do that, we're gonna use a current sum variable. So first of all, we're gonna have current sum would be equal to 0, and we gonna increase current sum by the number, right? And then right now we need to calculate the number of increment, the number of operation needed. So right now we're gonna calculate the current, the number, the number of operation needed. So how can we do that? Basically, we're gonna get right minus left plus one to get all of them equal to number right, right? So we want to increase all of them to right like this. We want all of them equal to right. So that means that the length of this segment from left to right, right, should be equal to right minus left plus one is this, and we multiply uh, by a right, by nums right. So that's basically the idea. So this one we multiply by right, and then we minus with the current sum we have. So that's the number of operation needed. And to avoid overflow, we're gonna have the one long right here, and then we're gonna shrink the window down by consider if the number of operation needed is greater than cake, we're gonna increase left by one, and then we're gonna reduce the current sum by num left, right? And then we will update the num operation needed right here. Actually, I should put it outside. It's gonna be make more sense. Yep. So we're gonna update the number operation needed like this, and then finally we just need to update the results, the longest frequency or the most frequency would be equal to max of the most frequency, and our right minus left plus one. And this we have most frequency would be equal to 0, right? Finally, we just need to return the most frequency. And I think that's all for this question. And the time complexity gonna be O. This one we use the two pointer approach, right? So the topic is two pointer, and this look gonna be ON, but we need to sort the array first. So this one gonna be ON log n, with n is the number of array, number of elements in the array, and then we have the space complexity. We don't use any additional array, so the space complexity gonna be O1. Yeah, that's all for this question, I guess. Let's see how it goes. Hmm, some typo error right here. Perfect. So that's all for this question. Hope it helps you guys. Thank you.